I'm Jeremiah Myers. I work with DrillSage as the development leader. Let's talk today about ensuring wellbore quality and integrity in real time. Let's get right into it. Major topic today is our work with our customer Blackbrush. We started working with them in 2023 after they had actually had multiple issues with stuck pipe and a couple of lost BHAs in their wells. We worked with them starting, as I said, in 2023. We completed 18 wells with them in total. And throughout that entire operation, our big goals were to make sure that we didn't have any stuck pipe issues, loss of primary barrier, well control issues. And we really wanted to make sure that we facilitated communication between the different teams of the operation. So we wanted to make sure that the rig team was communicating with the SMEs in the central office. And we wanted to make sure that operations engineers and geologists were also communicating with each other, aware of the same issues as they came up. So how did we facilitate that? We facilitated it by offering our RTAS system. RTAS stands for Real-Time Advisory System. We are pulling in around 30 curves from the EDR system, the electronic drilling recorder, and continually monitoring that using machine learning and AI techniques to look out for stuck pipe, influx issues, and other wellbore integrity issues. The system works by either sitting at the rig and receiving real-time data on location, or sitting in the cloud and receiving data from either the EDR provider in the cloud or directly from the rig in a lot of instances. So how do we bring these teams together and make sure that they're on the same page? The DrillSage system provides advisories to users, and there are two kinds of advisories. The first kind is an alarm, and the second kind is a watch. Alarms are very reactive, whereas watches are designed to be proactive. An alarm is just like what you would see in an EDR system. They're very simple and straightforward. If gas goes over 3,000 units, alarm. And those are the alarms that the driller sees on location. Unfortunately, they're also the alarms that the driller frequently mutes, shuts down, or disables because they're constantly firing. So we take on those basic alarms as well, and they incorporate into our notification system. Everything you can do with watches, you can do with alarms. But watches are really our claim to fame. Watches are built with the basis of physics, with the idea of raising situational awareness before we run into an actual hazard. So we're looking for the conditions that are conducive to creating hazards like stuck pipe and kicks, instead of looking for the final symptom warning signs. If we see gas as a result of an influx, that means the influx has already occurred. So alarms on gases are too late. What we're trying to do is provide proactive awareness. So before the problem is a big issue that needs to be taken care of, we're already aware that it's a possibility. The system's fully customizable, so it can be designed to work with your team. Geologists don't want to be made aware of every little issue that could occur at a rig. They might only want to know about things related to gas, the chromatograph, or maybe pore pressure versus ECD, things like that. Versus engineers who want to know a very specific thing about overpool, torque values, et cetera, et cetera. The power of the system is the dynamic customization behind these advisories and notifications. They can be built within the UI and launched into a shadow version of the wellbore so that it doesn't affect production. And it can, as many groups as needed can be created to make sure that it truly matches your operational needs. But we don't just enhance communication. We also optimize the well path. If you think about it, how much faster can you drill if you're not constantly drilling? How much faster can you drill if you don't have non-productive time caused by little issues? How much faster can you drill if you have a reliable KPI system that is reporting to you about your drilling optimization? Our system is all about improving real-time solutions, because as we're identifying these issues, we're also identifying corrective actions from the drill team. And we can use those corrective actions to train the AI, to train the system to be better in the future. The strength of DrillSage really lies in its ability to identify issues before they become hazards. And we do that by looking for the root cause of an issue. If you think about it, what comes first? Stuck pipe or overpull signs or cuttings loading signs? We don't generally just get stuck for no reason. There's always something that led up to that situation. And usually there's numerous things that led up to that situation. So what we're working on is making sure that we truly understand the root causes behind these issues. And then we're looking to identify those conditions to the users and to the users that really want to know. We don't want to let an executive know about some minor issue, but we do want to let him know if we've been fighting stuck pipe already for numerous hours. And that's what this system is really built to do, is to make sure that we're getting the right information to the right people at the right time. DrillSage helps you get in a groove and stay in that groove. We support and really push what we call steady state drilling. And in the field, they really just call that getting in a groove. But what is a groove, or what is steady state drilling? Well, steady state is when conditions aren't changing over time. It means that we're not accumulating new mass or new energy in the wellbore. And what's the opposite of that? The opposite would be transient or non-steady state. In unsteady state, we are accumulating mass, or we are accumulating energy. And mass shows up as cuttings. Energy shows up as pressure and torque and other output mechanics. Being in a transient state, a non-steady state, is not conducive to processes like safety and automation. In order to have an automated drilling system, we must figure out how to keep stable wellbores and how to stay in the groove at all times. Being in a groove makes sure that we don't run into the ROP conundrum. And you might ask, what's the ROP conundrum? Well, we all know the faster we drill a well, the cheaper that well is. And so, of course, we want to drill the well as fast as possible. But sometimes drillers will pursue that high rate of penetration without understanding the implications that he's causing in other places. So if you add more weight and you add more weight just to make sure that you're drilling as fast as you were before, you might not realize that torque is increasing to some crazy level, or that pressure has suddenly increased to some crazy level. We facilitate ensuring that as these changes occur, people are made aware of them, and the conversation can be had to understand if we really should be doing the things that we're doing. So the ROP conundrum is really, it's the challenge of balancing ROP while maintaining wellbore stability and integrity. And that's what we're pursuing. ROP conundrums existed on our first well with our client, actually. So if you look at this graphic that I have on the screen now, you'll see a crazy ROP curve, actually. The scale is 0 to 1,000 feet per hour. There are instances where they're hitting that 1,000 feet per hour. Their average is somewhere around 500 plus feet per hour. And the most notable thing about this curve is that it is back and forth spiky. There's no consistency here. It's like they push and they start making progress, and then they let up because of some other things happening in the wellbore. So the first thing that we really worked with our customer to do was to understand that this jagged drilling practice is really leading to a lot of the issues that they were having. And so you see on the screen, there are numerous advisories from the system that were being fired and sent to different people. But let me show you the opposite of that. Let me show you the second wellbore that we drilled with them. And what you'll see here is that the ROP curve is much more steady. In addition to that, we don't have a lot of advisories coming from the system. And that's because the ROP curve is steady. All the inputs are steady. The pressure is steady. Torque is steady. We're drilling a steady wellbore here. Much less risk of getting stuck or hanging as we make connections. We don't see any signs of that in hook load on connection, and much less risk of all these other issues that we're talking about today. And so what do we see as a difference beyond that? Well, we drilled 6,000 feet in both of these examples. It was around 33 hours to 36 hours for both examples. The steady state example did take about 3 hours longer, but again, just think about the hazards that we avoided, the risks that we avoided, and how everybody can be aware of these changes if we do suddenly run into something. So if suddenly in this second wellbore I see pressure increase, I know it's not because the driller is just hammering on weight on bit anytime he gets the opportunity. Sometimes these advisories actually lead to unintended consequences. So for example, in this screen, what you'll see is that we are firing advisories that are tightly coupled to mud flow out percent. And if you look at the mud flow out percent curve, what you'll see is that many of those values are below zero in the -70, ranging from -70 to -62. That's not what flow should be doing. Flow should always be 0 to 100%. So we fired these advisories, and the customer looked at them and said, "What the heck is your system doing? This makes zero sense." As soon as we looked at it, we realized that there was a problem not with our system so much, but with the sensors on location. The mud flow out sensor had just gone completely erratic and was not functioning anymore. So of course, we worked with the contractor to get the sensor working again, and continued working with the customer on this well without issue from here. But what we realized is that this is something we should be doing all the time. And so now what we're doing is we're looking at every curve that we use in these watches and alarms, and we're measuring the quality of that curve. And now whenever we see something like this happen, we can automatically let the RTOC know, the real-time operations center. We can let the rig know, or we can even let the service providers know and send them a message letting them know that we've suddenly lost data for a specific curve, or maybe that sensor just isn't giving us the data that we expect. And all of that happened because of the unintended consequence of measuring this curve while it was broken. The system works to identify issues as they evolve and escalate those advisories that we send out to different people based on what they should be made aware of. So if you look at this example from one of our wellbores, you'll see evolving sticking anomalies. You can see that pressure is raising, torque is raising, but there are no input changes. RPM is steady, flow is steady, and the amount of weight being applied is steady. So where is this increase coming from? The other thing you'll see on the screen is that we're starting to get excessive overpull whenever we go to make a connection. And that's something that our system is very adept at identifying. So what we do in this system is we send these messages out to the operational team on this first set of advisories. And then as the condition gets worse, we escalate it, as we've mentioned before. So how do we escalate it? Well, if you look here, what we do initially, as I said, is we send it to the rig personnel first. We find that including the rig personnel in the first set of alarms really removes a lot of those questions and concerns they have as far as Big Brother goes. We don't want them to feel like somebody's looking over their shoulder telling them what to do. We want them to feel included and involved. Nothing's worse than being told you have an issue at the location you're at by somebody who's 100 miles away or 1,000 miles away. So it's important to include them early. And in this example, we did let the rig personnel know first. There was a sticking watch that occurred at about 4:15 in the morning, and then a cuttings loading watch that occurred at 4:18. So both of those went to the rig personnel. But as the problem continued, as we kept seeing that pressure and torque trend rise, and once we started to see those overpull signs, we escalated the issue. And then we brought in the operations team, the support subject matter experts that work in the office in the central location, the geologists, the engineers, and made sure that they were aware of the issue autonomously. And then once again, as it continued to get worse, we escalated once again. And then we're letting actual management know about the issue. And in this instance, there's actually an executive on this third level. But again, I just want to point out one more time, these groups are very customizable. If you want to have 5 groups, you can. If you want to have 10 groups, you can. If you want to have 5 users in one group and 15 in the other, that's just fine. We are built to match your operation and not cause a lot of new work that's outside of what you're already doing. If you take anything from this conversation today, I hope it's these 3 points. The first is that we provide structured and repeatable risk mitigation for the human factor. The second is that we're a non-destructive integration. It's not a new parallel process. You don't have to change the way that you're working already. We fit in with what already exists. And the final thing is that we improve the decision-making capability. It's so much easier to make decisions when you know what's already going on. It's easier to have ad hoc calls with personnel if everybody knows what is going on and is on the same page. If you have any questions or you'd like to have a conversation about this, please don't hesitate to look me up on LinkedIn, send me an email, even shoot me a text message. I'd love to have the conversation. Thank you.